Hello guys, this is Showman from Oil and Gas Field Quality Control. Today our subject is water filling for Hydrotest. This series will have one or two more videos. Let us start. Before starting water filling activity, we need to consider few things. The pipeline or piping system should be fully constructed. Though it seems it is a very basic point, you can say, if the construction not finished, how hydrotest will be done? Let's say we missed one drain or vent connection and hydrotest completed. Then for installing this drain or vent connection, we might need to get a waiver or we need to rehydrotest the system. So this is better to involve the quality department. Inspector should check one by one and should generate a punch list for hydrotest where all the A item or mandatory items should be closed. What is A item? A item, it can be quality related item, it can be incomplete construction, incomplete non-destructive testing, incomplete safety requirement. It can be anything which is mandatory items considered as A item. Let's say painting, coating or touch-up can be a B item or non-mandatory item for hydrotest. See, these A items can be different for different activities. Let's say after hydrotest, we will do reinstatement. So cleaning the area is not a mandatory A item for hydrotest, but for reinstatement before commissioning or pre-commissioning activity, cleaning the area, housekeeping, removing all the unwanted things from the site is a mandatory item for reinstatement, but B item for hydrotest. So this way, A item for hydrotest all should be closed before starting the water filling. Internal cleaning of the pipeline shall be completed. Test header, test manifold, whatever is applicable or temporary, permanent scraper launcher or receiver shall be installed on both sides based on the test limit. Full lines are backfilled, adequately supported to prevent any safety accident. So there might be more points, but I am only mentioning some basic point which is in my mind. Water filling preparation, there are quality or documentation part and there are some construction part. Let us discuss the quality part at the beginning. Source of the water identified and tested by the third party, means client approved third party. Water test report is accepted. This is to make sure that water is not harmful for the pipe material. Section or limit of hydrotest has been identified and test setup has been completed. The method statement for water filling, hydrotesting, dewatering, drying, layup is prepared and accepted by all the relevant party. It can be the project management. It should be reviewed by the plant proponent because it is their property, and hydrotest is the final acceptance of the line. So they must check the procedure and they should be convinced before they accept the system and the test result. Apart from this, vital quality document is hydrotest package. In hydrotest package basically contains all the mandatory diagram, drawing, hydrotest diagram with highlighted test limits, inspection checklist and the reports, let's say water test report, and you need to attach the torquing, bolt torquing report. You need to attach the pressure gauge, relief valve, test recorder, temperature recorder, calibration reports should be attached in the hydrotest package. So this has to be submitted before any activity related to hydrotest started, and it has to be reviewed and accepted by the project inspection from the client. Water filling part is part of construction. How it is selected, I will discuss a bit more in the next slides. Chemical, oxygen scavenger or biocides, whatever applicable has been selected and procured and ready for injection. Dosing and metering pump should have enough capacity for injecting chemicals at a specific rate. Brake tank, water filling tankers, hydrotest manifold, rated hose pipes, connectors, fittings, all are arranged as required. All necessary water permits arranged. JSA means job safety analysis, potential hazard, safety hazard, which are reflected in JSA. This is also approved. Safety measures are adopted at site before starting the water filling activity. Here for the chemical, oxygen scavenger and biocides, I am making a separate video with little bit more detail so that you will understand the calculations and the types of biocides, some examples of biocides which I have discussed. Please refer to my next video which I will be posting after this. Based on the material category of the pipeline or piping system material which we are going to hydrotest, there are some corrosion related calculations on pitting resistance equivalent number. In short, PREN, pitting resistance equivalent number. This is one of our client. I have taken from their categorization table for the education purpose to discuss the methodology, how we are categorizing the material based on the severity, and then we are taking care of the water quality, chemical treatment and layup requirement. Basically, you can see there are three categories, 1, 2 and 3. 2 is having some subcategories, 2A, B, C, D. Category 1 is carbon steel, galvanized, low alloy steel, and category 3 is non-metallic like RTR, RTP, HDPE, like that. There is an assigned PREN number at the last column. This PREN number and this category decides the requirement of water treatment or types of water we need. You see the category 1, which is basically carbon steel or galvanized or low alloy steel, the chloride content had no restrictions, and all categories the total bacteria requirement is less than 10 to the power 4 per milliliter of the water. SRB means sulfate reducing bacteria count per milliliter of water should be less than equal to 10 cube or 1000. Oxygen concentration for category 1, 2A and 2B should be less than equal to 20. pH range for hydrotest water required for all categories should be within 6 to 9. And total suspended solid in parts per million should be less than equal to 50. And chloride concentration requirement, stainless steel and alloy. Category 2A is less than equal to 50 and category 2B is less than equal to 500. And for other categories 2C, D, E and non-metallic, category 3 has no restrictions of chloride content requirement. Category 3 is little bit relaxed since it is non-metallic, so there are no restrictions of bacteria count, SRB count or oxygen concentration. The pH range and total suspended solid is still required because dirty water is not helping a system. It's very difficult to remove the suspended particle which is deposited in the pipeline, so it should be little bit of clean water. Water testing, there are some requirement. I have a separate video, but still I am discussing the basics here. The quality of the water shall be reconfirmed by sample testing from client approved third party within 2 weeks before the initial water filling preparation for the hydrostatic testing. In case of multiple water resources or water tankers or truck use, means you are having 2, 3, 4 water tankers, they are collecting water from different sources. We need to make sure these waters in between they are not reacting each other and they are forming some scales or some sediments which will be deposited or reacting with the pipe material itself. If the water used in the hydrostatic test or wet layup process is from more than one source, also we need to make sure that the mixing of water will not cause any scaling or a reaction. Water can be reused for hydrostatic testing of similar material categories as in transferring water from a pipeline segment to another or from a tank to another. We need to test some water if we want to reuse. Water shall meet the water quality requirements. So every time we need some specific elements of the water to be tested. This is very clear in the client standard. Water to be used for hydrostatic testing of material category 1 shall not be reused for category 2A and B. So what is category 1? It is carbon steel, low alloy steel, where carbon or ferrite contamination is expected. So the water coming out from this type of system after hydrostatic testing, if you use in category 2, which is stainless steel or alloy steel category, it will contaminate the surface of the pipe. It may decay or create a corrosion in the pipeline. So it is not allowed or recommended. Here are some sample of water testing report from the third party. You can stop the slide to check the basic requirements here. This is from international standard and to satisfy the client standard also. This is also a report from our client. You can see the basic requirements here. It's just for a reference. This is a marked hydrotest diagram where test limits are identified with some red arrow. There is a test limit written on each and every test. Go to the table, which is also reflected in hydrotest pressure table from hydrotest drawing. You can see here the test number 1 and 4. The test fluid is water. The strength test is 3330. The duration is 2 hours. Even relief valve setting is also there. And the tightness test mentioned here, 5% less than the strength test, and then it is limited by the class 900 valve. Let us check the test pressure from where it comes from. It comes from basically the design calculations given by the designer, calculating the system based on the each and every component present in the system. Let's say valve, flange, elbow, fittings, pipe body, and then they calculate each and every parts can take maximum how much hydrotest pressure. So then they will put the minimum pressure on that. For example, in this safety instruction sheet, this is the final table after the calculation. Here it is limited by the valve body, and the test pressure here is 3375 psig. Now let us go for the water filling pump. This filling is our subject today. First of all, we need to check the pump capacity. What is pump capacity? It is the rate at which the pump can push fluid through the system. Based on this definition, pump capacity is expressed as fluid volume per unit time. Some of the most common units of pump capacity are gallons per minute or GPM, liters per minute or cubic meters per hour. Some selection criteria of the filling pump. Let us have some practical data. Flow rate of the pump. This is one of the capacity. So 80, 120, 200 up to 1500 cubic meters per hour. When you're going to purchase a filling pump, you will ask or you will put the specification what you need. Pressure rating of the pump can be 12 bar, 13 bar, 17 bar. There is one more advanced pump which is called multi-staging pump. It will give you 30 bar, which is approximately equivalent to 400 psi. Your filling pump is only filling water for you. Apart from that, if it is giving you a 400 psi of line pressure, after the water filling has been completed, air has been removed, you have a pressure tight line of 400 psi. So this is amazing. Then you just install your pressure pump and then you go pressurize maybe within an hour or something, depending on the length of the system. This is amazing. If you have a bigger line, better to use a multi-staging pump which is already giving you a basic high pressure of the line. Pressure head of the pump. So this is expressed in meter, let's say 50 meter. So it can lift water at a height of 50 meter maximum. I will discuss how to select a filling pump based on some site scenario and considering the availability of the pumps in the market. For calculating the site scenario, you need to first decide the volume of water you need for the test. How you will calculate? What is a pipeline? It is basically a geometrical shape equivalent to a cylinder. So volume of cylinder is pi r square L. Pi is equal to 3.142. It is a fixed value. R is the inner radius of the pipeline, and then L is the length of the hydrotest section of the pipeline. So if you calculate, put your values, you will get the volume of water in meter cube or liter, and then you will get that how much water you need to fill. So now we need the filling rate. How we will get the filling rate? So this depends on the client's criteria also. Let's say your client is telling you need to complete the test within 30 days. There are many activities: filling, pressurization, depressurizing, drying, layup, and then finally reinstating the system. So from the planning, you find that you need to fill that line within 7 days. Otherwise, you cannot achieve these 30 days of completion. So now, rate of filling. Rate of filling, let us assume the volume of water, for example, 20,000 cubic meter. So if 20,000 cubic meter water we need to fill in 7 days, so per day you need to fill 2,900 cubic meter. And let's say we are working 8 hours per day, 2,900 divided by 8. So per hour you need to fill around 414 meter cube. Apparently, means in a direct way, if there is no other constraint, our filling pump capacity should be more than this 400 meter cube per hour. Now let us consider some other facts which also we need to consider before we start filling and purchasing or renting a filling pump. The most crucial thing is the availability of the water. You need a continuous supply of water for doing the filling work. Let us say we have a bigger filling pump, but supply of water is limited. Means the water can give you only a supply of 200 meter cube per day. Means you got a water well nearby which has good water for your hydrotest. You already tested it, but the owner of the well told you that they have a lot of daily consumptions which is mandatory, which is purpose of that water well. So they have to fulfill the daily consumptions first, and they have an additional, they can give you additional, let's say 200 meter cube per day, and you have a target of filling 2900 cubic meter per day. So what you will do, if there is no other way of getting water, then your total filling will be reduced to 200 meter cube instead of 2900. So your filling pump require will also be very small. And in case you want to add more water through water tankers, they are bringing the water from different water wells from far, and there are multiple water tankers. All waters are acceptable on quality point of view, but in that case you need to deposit the water from water tanker to a break tank, his stationary tank near the filling station, so to get a continuous supply of water, and you get maybe another 200 or another 500 cubic meter per day. So you need to consider all these things. Then per day, let's say 1000 cubic meter of water, then your per hour consumption divided by 8, and you need to select a filling pump capacity little bit more than that for not to go to the maximum limit of the pump. Head capacity of the pump. This is another consideration when you hire a pump or buy a pump. If the elevation of the pipeline is different, let's say your filling point is low and you are delivering to a very high point, in between there is a 50 meter, 100 meter high hill and the pipeline is crossing. So this elevation difference is the pressure head of the pump. So if there is a 100 meter high, you may select a filling pump more than 100 meter or 120 or 150 meter capacity. Otherwise the pump will not able to push water to that height. So this is head of the pump. Next, the last one, the water quality, based on the PRN number you may need to add, or the number of days the water will be attached with the system. If it is more than 14 days or 30 days, the client have a mandatory requirement of adding the biocides and oxygen scavengers. Then if the filling rate is too high, the corrosion inhibitor or biocide rate also to be increased. If we cannot, then also we have to reduce the rate of filling. Again, you see it is restricted by this chemical injections. So if you restricted by one of these points which I have discussed now, you cannot install a pump over 414 meter cube, which is your target per day. So target can only be achieved when there is water. Here is a typical water filling diagram setup. You can see there is a basically water source. This can be a break tank, this can be a water well. There is an injection pump also, filling pump also. Injection pump will inject the chemical and filling pump will inject the water in the system through some restricted methodology, through some valve, non-return valves. This can be a test head at the end of the system, and water will be pushed through scrapers. There will be generally always two scrapers. One scraper is pushing the air in front of it, and between two scraper we will also introduce some water. There will be a water column. In case some air bypass the first scraper, the water column between two scraper will prevent it, and thus all the air will be pushed away from the system from the vent valve situated other end of the pipeline. Pipeline generally don't have any vent or drain in between, so they will have a vent valve installed in the test header or manifold. Air must be go out from that area, and there will be a airless tight filling for the system. Hope I have discussed the water filling strategy, construction methodology or quality requirements well. Here are some photos for your just ready reference. The pump at the left top, it is a generally popular models of filling pump used in the pipeline. There is a hand pump which are used to fill small system or piping or valve testing, double diaphragm pump. And right side, the big unit, you can see this is a unit for the whole testing that can feel, that can pressurize, and even you can monitor the system digitally. It is connected with some sensors and systems, so you can check the filling rate and pressurizing rate. Now you will see some brake tank at the left. It is basically a tank, and you just fill from the water tank to the tank, and from the tank you fill the line through a filling pump. Sometimes we can fill small system directly from the water tanker also. The photo at the right bottom. This is a photo of Hydrotest manifold, which is a mandatory safety requirement. There are no return valves, and there are a lot of choking system which can be closed during any accident or something. And this is highly rated, at least 1.2 times more rated of the Hydrotest pressure, so that any accident it can be prevented by the valve. For Hydrotest manifold and its design and preparation, I will make a separate video for you. This is another interesting subject for us. This is a photo of a test header. You can see instead of Hydrotest manifold, you can use a test header. But for pressurization and final maintenance, we must use a Hydrotest manifold. This is installed, prepared with the same pipe material, installed at the end of the pipeline with a flanged connection, and sometimes it is welded also together with the pipeline. Later we will cut and install the connections from the pipeline. So the test header also have some inlet, outlet, draining mechanism installed in the system. And these are some rated hose pipe, whip check or arresters. Why we need to use the rated hose pipe? Somebody says it is only Hydrotest, but remember, the Hydrotest pressure is such a big pressure which the system itself will never face in its life. So means Hydrotest is very dangerous operation if you not follow the safety. Always use the fittings and the hoses at least one step higher rating than the system, so that it can withstand any accident or any unwanted extra pressures from the line or from the system during the Hydrotest. These are some high rated fittings, 10,000, 15,000, 20,000. There are some needle valves, high rated pressure testing. So hope you guys, the idea is clear with your mind. If you are getting benefited from this type of video, please don't forget to share and subscribe my channel, and please hit the like button to inspire me more. And if you have any query, please write in the message below. I will try to reply all of you. Thank you. Signing off for today, Showman.